Hi there, hope you have a fantastic day today. This lesson I will teach you annuities. Of course, there is a PDF versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one, after Jacob has a part-time job, he starts to invest $150 at the end of each month. How much money will he have at the end of 10 years if interest is paid at 6% per annum? So first of all, we need to know that he invested $150 each month and the interest rate is 6% per annum. So therefore, the interest rate will pay by monthly. In another word, compound monthly. So what I do, I just write this down first. So we know that P is $150 and the interest rate is 6% per annum, but because it's compound monthly, because it deposit every month. So therefore we must divide this by month. So that is 12 months in a year. So 6 divided by 12 is 0.5. So the answer is 0.5% per month. Okay, keep that in mind for me. So N is number of times that he deposits. So N is because he invested $150 each month. So 10 times 12. So that is 120. So now let's just go through the process. So first of all, we know that at the end of first month, that means I1. Because he invested at the end of each month, so this means that at the end of first month, he will have $150. Okay, and there is no interest because at the end of the month, he just deposited. Okay, and at the end of second month, so this means that I1, that is the first month, he has interest. So we times by 1 plus 0.5%, 0.5 over 100. But then he also deposit $150, okay, at the end of second month. So that means the $150, there is no interest for that. So we know that 1 plus 0.5% is 1.005. And we know that A1 is 150. So let me just write this down. So that is 150 and we times by 1.005. We add 150. So that is at the end of second month, okay? And then at the end of third month, so at the end of A3, that is at the end of third month. So the second month, we have interest and plus he also invests another 150. So in another word, A3 is equal to A2 times 1.005. That is the balance. And then we add 150 on top because Jacob invests another 150 at the end of the third month. So therefore, A2, don't forget, is this one here. That is A2. So let me just rewrite this. So A2 is 150 times 1.005 at 150. And we need to times 1.005. So times by 1.005. And don't forget, we need to add 150. There you go. That is A3. So let me just rewrite it out in an expanded form. So we just times this together. So that will give me equal to 150. We times by 1.005 squared. And we add and we times this together will give me 150 times 1.005 and we add 150. So let me just rewrite in ascending order. So let me move this up so that A3 is equal to, so 150, we add 150, we times 1.005 and we add 150 times 1.005 squared. So that is the balance at the end of third year. In another word, this is how much he has in his account at the end of third month. Okay, so you can see at the end of third month, so 150 plus 150 times 1.005, we add 150 times 1.005 square. If it's A3, so A3 is give me all the way to 1.005 power of 2. So therefore, we need to work out at the end of 120 months. So A 120. So therefore, we have 150, we add 150 times 1.005 at 150 times 1.005 square, we add 1.005 power of 119, and you can see A3 it give me all the way to power of 2. So 120 will be one less, so 119. Remember that for me, okay? So now we just add this series together. So we know that the first term is 150 and the common ratio is term 2 over term 1, which is 1.005. That is the common ratio. And what we do now is we find the sum of this series, sum of 120. But we know that sum of n using this formula is a r power of n minus 1 over r minus 1. So a is 150. Let me just write this down. S of 120. So a is 150. So 150. R is 1.005 power of n. And don't forget, n is 120 terms. Even though it's power of 119, but then because it's the first term, is 150 times 1.005 power of 0, if you like. So therefore, it's 120 terms. So 120 minus 1 over 1.005 minus 1. So now what I do, I just put that on a calculator. So I just go fractions 150 brackets 1.005 power of 120, and we minus 1, close brackets, and then 1.005 we minus 1. So there you go. So $24,581.90. So that is equal to $24,581.90. So there you go. Please pause the video and try this one yourself. Hi there, I'm back. How did you go? So let me go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first of all, we need to know that Samantha's dad deposit $200 every year, and it compounds yearly, of course, because 9% per annum, and his deposits every year. So the interest rate is stayed the same, so we don't need to change. So R is 9% still the same, and N because he deposit every birthday. So when Samantha reach 1 year old and he start deposit, okay, keep that in mind. So that means N is 18. So therefore, first birthday, that is A1, Samantha will have $200. Because when Samantha reach 1 year old, her dad will deposit $200 for her. Okay. Now on the second birthday, so the first $200 we have interest on top of that. So the balance for that is 200. So times 1.09. Okay, using compound interest, of course. And then he also deposit $200. Okay, so keep that in mind. And then A3, is equal to, so which is A2 times 1.09, that is the balance, and we add $200. So there you go. And we know that A2 is this one here. So let me just rewrite this out. So that give me 200 times 1.09, we add 200. And we times by 1.09. And this is the 1.09 here. Okay, keep that in mind. And don't forget the 200. We need to write this down as well. So let me just expand this out. So that will give me 200 times 1.09 square, because this time that and this time that. So we add 200 times 1.09 and we add 200. So there you go. So let me just rewrite in ascending order, so makes it easier. Okay, you don't have to, but it's just easier, that's all. So that is $200. We add $200 and we times 1.09 and we add $200, we times 1.09 power of 2. So there you go. So now you can see the pattern. A3 will give me 200 plus 200 times 1.09 plus 200 times 1.09 square, one less. Okay, so keep that in mind. So therefore, we need to work out A of 18. So A of 18 is 200. We add 200 times 1.09. We add 200 times 1.09 power of 2. We add and we add 200 times 1.09 power of 1 less. Okay, keep that in mind. So 17 instead. So there you go. So now what I do, I just add this series together. So we know that A is the first term, which is $200. And the common ratio is term 2 over term 1, which give me 1.09. So now we know the formula for this. S of n is A r power of n minus 1 over r minus 1. And we know that A is $200. And then R is 1.09 power of. Now don't forget, because this is 17 and start with 200 times 1.09 power of 0. Remember, so from 0 to 17 is 18 terms. So that is power of 18. And we less 1 over R is 1.09 minus 1. So now I just put on a calculator. So I just go fractions, 200 brackets, 1.09 power of 18 minus 1 brackets, and then 1.09 minus 1. So there you go. $8,260.27. So that is equal to and 27. So therefore, so there you go. I hope you got it correct, and thank you so much for watching. Bye.